In this video, I'll go through problem number 32 and exercise 3, 7.3 in its entirety. And after I finish 32, I'll go through the beginning of problem 34 as it is useful to demonstrate a key concept, one that might very well come up on the next test. So 32 and then the beginning of 34. In 32, we're asked to derive b. B appears twice. B appears as a part of the consequent of both line 1 and line 2. So maybe not all that helpful in immediately unraveling the problem for us, but there is a rather obvious step for us to take in beginning to solve 32. Line number 3, premise number 3, demonstrates the textbook case of De Morgan's. So since that's an obvious move for us to make, hopefully that jumps right out at you. De Morgan's 3, let's see where that takes us. So in this particular case of De Morgan's, distribute and flip, apply the tilde to the Q, and also to the T, start with a dot, switch it to a wedge, we get not Q or not T. So what can we now do with line number 4? Well, line number 4, not Q or not T, not Q is the antecedent to 1, not T is the antecedent to 2. It sounds like we can set up here a constructive dilemma. And fair enough, this is a complex case of constructive dilemma. We haven't really seen anything quite this complex just yet. But this step, something quite similar to this step anyway, will come up frequently throughout the course of 7.4 and then even into 7.5 and 7.6. So add this to your toolbox, complex case of constructive dilemma. Of course, to pull off CD, we need 2 horseshoes joined by a dot, which we don't have, but we do have 2 horseshoes. So easy enough to jam them together via dot with conjunction. So that'll be my next move here for line number 5. 1 and 2 conjunction, smashing the 2 together with a dot. And of course this will involve brackets to clearly identify the dot as the main operator. So not Q, horseshoe, C and B. And now line number 2, not T, horseshoe, B and H. And of course I need to put the 2 lines respectively in brackets to again clearly identify that dot as the main logical operator. So now with line number 5, and that was the tricky step, realizing that we can do constructive dilemma, I'm now ready for that CD with 4 and 5. 2 horseshoes joined by a dot, fairly complex, but nonetheless, basic pattern here. 2 horseshoes joined by a dot, antecedent of each joined by a wedge in line number 4. And so we get out, as a result of 4, 5, CD, we get out the consequent of each horseshoe joined by a wedge. C and B or B and H. C and B or B and H. So line number 6 here is the fruit of our labor here. This is the result of our hard work, carrying out steps, our lines number 4, 5, and now resulting in 6. So the question becomes, what can we do to line number 6? This obviously has got our B's in it, B in the first disjunct to B in the second disjunct, and that's what we want. So what can we do to line number 6? Well, check your rules, and you'll see that line number 6 is pretty darn close to the textbook case of distribution. There is, however, one intermediate step that we need to conduct before we're ready for that distribution. And again, if you don't have it committed to memory just yet, consult the visual explanation as provided for you in the text. You'll see that to do distribution, we first of all need a common variable, which we have, the b's, but the common variable needs to come out front, in this case in both disjuncts. So the second disjunct is ordered properly, the b is out front, but the first disjunct is reversed. So the intermediate step is to do com, 6 com, just to the first disjunct, of line number 6. The second disjunct is ordered just as we want it. So com to the first disjunct of line number 6, instead of C and B, we want B and C. So there's the com, the rest of it stays the same, B and H. And now we're ready to do our distribution. In this direction, we're going to suck out, so to speak, we're going to suck out the like variable from each of the disjuncts, which obviously is the B. So take away the B, and then we get the leftover parts, the C and the H. Main operator starts as a wedge, so flip that to a dot, use the wedge as the leftover, and that's the aggregate of 7 distribution. So we want the B by itself, and the main operator now in 8 is the dot. So real easy to finish this off. 8 simplification, that gets us the first conjunct by itself, and we're done. So that's 32. The key step, again, step number 5, to set up the constructive dilemma. complex case of constructive dilemma, but the key to unraveling the problem. And you'll see something quite similar to that come up a few times down the road. So add that to your toolbox, it'll come in handy. So on now to problem number 34, and for 34 I'm just going to walk you through the key step to the problem and leave the rest of it for you to solve. Problem number 35, the very next problem, demonstrates the exact same concept that we'll now go through in 34. So if you're able to finish off number 34 after I give you the key to the whole problem, then try to go through 35, in which you'll demonstrate the same exact concept. So in 34, we're after the n. N, once again, appears a couple times, so not something that's tremendously helpful right off the bat. And in 34, we're just given two premises to work with. So let's think about what we could possibly do to begin the problem. Of course, could always do addition, could always do conjunction, but there doesn't seem to be an obvious reason to do so at this point, so we'll leave those two aside. Excluding addition, excluding conjunction, what could we possibly do here? And the answer, unfortunately, seems to be not really much of anything. We seem to be completely stuck. Line number 1 looks like a case of distribution, but to do distribution, we would need a common variable between the two disjuncts. But here, we don't have that. We have, rather, 4 unique variables, m, n, o, and p, respectively. So it's close to distribution, but it doesn't seem to fit the bill, doesn't seem to match the pattern exactly. So here's the trick. We can, in fact, do distribution to line number 1, but certainly it's a much more complex case than anything we've seen before, and the visual explanation of the rule in the text wouldn't at all lead you to believe that you could do this. So get this down. I wouldn't expect you to get this on your own, but this step will come up a couple of times. In fact, it will come up in the very next problem, number 35. We're going to treat the first disjunct here, m and n, in its entirety. We're going to treat everything in parentheses here as though we're just a single variable. And so what we'll do, this is the trick, what we'll do is distribute m and n together as though we're a single variable, first to the o and then to the p. So it's a complex case of distribution. Usually you just distribute a single variable. This time we'll distribute the entire thing here out front as though it's a package deal. So here's what it will look like. M and n, and we need to leave those parentheses in. M and n distributed to the O, and then M and n, still leaving in the parentheses, distributed to the P. The main operator here starts as the wedge, so we need to flip it to the dot and use the wedge as the leftover operator. Now to clearly identify that dot as the main logical operator, we need to put in our brackets. So that's the key step here, that's the complex case of distribution. One distribution. Now from here, the main operator in line number 3 is the dot, so you can simplify, get out the first conjunct by itself. You could then do a com and a sim to get the second conjunct by itself, combining 2 steps into a single line. A com and a sim will get you m, n, n, or p. And then from there, with lines 4 and 5 at your disposal, you can do another couple of coms to get the single variable out front, and then you're faced with a couple of more distributions, and eventually this process will lead you to getting the n by itself. So see if you can't unravel 34 now that I've given you the key step by yourself, and then of course check your answer when you're finished in the back of the text.